All right, welcome class. So today we're going to talk about taxes. I know it's everyone's favorite topic. It's been hit pretty hard because, as the name public finance implies, the government, the public sector has to finance itself somehow, and the way it does that is typically with taxes. The problem with these problems is kind of ironic for economics, and the problem is that when you solve these guys, you have choices. So the problem is choice. If you didn't have choices, I think these problems would be a little bit simpler. In particular, the problem that you have is you can think of this as a tax on the producers, and then you have to shift the supply curve, or you can think of it as a tax on consumers, and then you shift the demand curve. And often it doesn't specify which, because we know that in practice taxes are neutral. It doesn't matter who you tax, so we really don't bother specifying. So, since you have this choice, there's two ways to do the problem, and sometimes it gets confusing where you start doing it one way, and the results you get, don't really jive with what you expect, because you're expecting the results to be what you get from doing the problem the other way. It turns out that you'll ultimately get the same answers, it's just how you interpret them. It'll look like you get different answers, but the proper interpretation, will get you the same thing either way. The way you're going to solve this problem of choice is that you won't give yourself a choice. We're going to think of every problem in this class as if it's a tax on producers. So we'll always be thinking of this as shifting the supply curve. We'll always be plugging in the change into the supply curve, the supply equation. You don't have choice, all right? We are eliminating choices. So we'll just do no choice. It's a great country, free country. You're free to choose not to choose. So we have this cute guy here, this little Shiba Inu. I think his name is Daifuku. And he has this cute little teddy bear. He loves his teddy. And then we find out that to help the government raise some money, they're going to have to start taxing teddy bears. And that's not going to make Daifuku happy. So this is what he looks like afterward. Oh, not a happy Shiba. There we go. Now you can see him. So he's angry. We're taxing teddies. And let's work out the implications on our next slide. So we start with this demand equation and this supply equation. The original P and Q, you can solve for them. If I did this right, it's Q is 7, P is 3, so the price is $3 per teddy. There's 7 teddies purchased. I think they were all purchased by Daifuku. And now we're going to add a tax of $1. So we know on the graph, we could shift the supply curve, although it turns out it actually makes it a little tougher to see what's going on. Because if I add in another part to this picture where there's a second curve here, and now there's all these dotted lines crossing, and there's all these points and stuff, things get kind of confusing. So often I don't like to draw it in, but if you do, let's go ahead and let's put it in as a dotted line. So, I don't want that in red. Put this in black. Dotted line, this is like, sometimes we call it effective supply. All right. So you see that there's this new intersection up here. Here's our original intersection. These 2 points are important. We'll come back to why later. But we can see that the new price is going to be higher. That's the price the consumers are paying. But we know that the producer is not going to get to keep all of that money. If the consumer now has to pay, say, $3.50, there's a tax of $1. So this point down here directly below our new intersection represents what the producer gets to keep. That point will always be on the original supply curve. So we'll have a point that's only on the demand curve, a point where the original two intersect, and a point here only on the original demand curve. That represents what the producer gets to keep. Sometimes I label that PP for producer, and up here we could call this PC for what consumer pays. And now we've got to solve for the two. What we're going to do is we're always going to use this, make adjustments to the supply curve to represent this new supply curve. And then we'll be solving for PP. We're always going to get a higher price than the original price. So the substitution we make is that we replace P here in the supply curve with P plus the P minus the tax. Because what you actually get to keep is not the full price the consumer pays. It's you keep that minus the tax. So our new supply curve, let's cross out this old supply curve. Our new supply curve is QS plus 1 plus 2, and now in parentheses we're going to replace this with P minus 1, because the producer actually gets to keep only P minus the $1 minus the tax. And then we can work this out, simplify this out, and get 1 plus 2P minus 2. And now you're saying, wait, this looks like it has now shifted down. It's like a minus 2 at the end. That's because we've written this as Q as a function of P. So we're thinking of it where Q is the Y variable, Q is on the vertical axis. That's not what we're plotting. What we're plotting is P on the vertical axis. So you'd actually have to rearrange this. And if you did that, you would see that it actually is a shift upward. So this is totally consistent with what we've drawn. It's just a little confusing because we have P and Q kind of plotted backwards. You can do this, I think it's worth it to work this out and rearrange it so it says P in terms of Q, and you'll see that it has shifted up by exactly $1. So now we can combine this equation with this equation and solve for the new prices. I'm going to leave that to you as an exercise. What you should get is that the new consumer price is 67 cents higher, approximately. So the new consumer price is $3.67. And then we know that the producer gets to keep that price minus $1, so he's going to get $2.67. As a brief aside, what does this tell us about the elasticities? We see the consumer is paying 67 cents extra, whereas the producer is getting to keep, well, he used to get 3, now he gets 2.67, so that's about 33 cents less. So the consumer is paying more of the incidence. What does that tell you about the elasticity of the consumer compared to the demand curve compared to the supply curve? All right, so now we have our new prices. We have what the consumer pays, what the producer keeps. We can find our new quantity. Let's see what that would be. That would be like 633. I think that's right. So the new quantity is smaller, like we expect. If you get numerically a bigger quantity with a tax, you know something went wrong. So just go back and check your math. You're always going to get a smaller number. And now finally we can think about calculating this deadweight loss. The nice thing is those 3 points I highlighted earlier always triangulate the deadweight loss. We have our original point here where they intersect. We have our new intersection up top. Let me get the highlighter. So our original point, our new point, and then vertically down from that new point, we get our point on the original supply curve. These three trace out our deadweight loss. So this red shaded area is our deadweight loss. And then calculating the area of this triangle is pretty straightforward. The base is always the size of the tax, so that's $1. So it's 1/2 times that base of $1. And then the height here is this change in quantity. So that was 0.67. And then we can calculate the actual value of that deadweight loss. I don't have a calculator, so it's going to be 1/2 times 1 times 0.67, which is 0.33, I think. So that's how I recommend doing all of these tax problems. To get the deadweight loss, your 3 key points are going to be the original equilibrium, that's the market equilibrium, then your new intersection where you shifted supply, and then directly below that on the original supply you get your third point, then your deadweight loss is the shaded area between all those guys. In terms of finding these numbers numerically, just replace the P with P minus the size of the tax. That's what we did here. Don't forget the parentheses, because here it makes a difference. It's 2 times P minus 1, so that becomes 2P minus 2. If you forget the parentheses, you might just say, oh, it's 2 times P minus 1, but then you'd have minus 1 over here, not minus 2, and you'd get the numbers slightly wrong. By taking away our choice and eliminating the focus on the demand side and what a tax on a consumer might look like, we've given ourselves a way where we're always going to be solving first for this higher price, what the consumer pays, and if we want what the producer then keeps, we just subtract the tax from that consumer price, and we have our foolproof method of getting the deadweight loss. So hopefully this makes these problems easier. You can extrapolate from here and do all sorts of more complicated problems. You could imagine now expanding this tax. What is that going to do to the prices? What is that going to do to the deadweight loss? You could imagine starting with a tax and eliminating it. Then you'd be going from a deadweight loss to no deadweight loss. As long as you use the graphs to work these things out, I don't think they're too complicated, although there's lots of ways to ask and to think about this model. The real catch is to always make sure that you go through the steps slowly and methodically to avoid making some dumb mistakes. Alright, hopefully you enjoyed this video and my terrible handwriting with my shaky hands. If you didn't, or you have any questions, just feel free to email me. I'll see you guys on Monday or Tuesday.